Yesterday we spoke about the derivatives of inverse trig functions. Today we're going to generalize a bit and speak about the derivative of all inverse functions. So here's an inverse function, y equals f inverse of x. What that means for y to be an inverse function means that it is the inverse of a specific function. It's not like inverse functions are their own type of functions, like trig functions or quadratic functions. It just means that there's a relationship between these two functions, f and f inverse. We're going to find the derivative of the inverse of a function if all that we know is what the original function is. So, like we saw with the trig inverse yesterday, what we're going to do is rewrite this. Y equals f inverse of x, that's another way of saying that x equals f of y. If y equals f inverse of x, then x equals f inverse of y. And we can then take the derivative of both sides. That's what we called yesterday implicit differentiation. Take the derivative of both sides in respect to x. Derivative of x is 1. The derivative of f of y is f prime of y. Times, this is the big thing, times dy dx. Remember that this dy dx that we have here, that's talking about the derivative of our inverse function, so we can write that as f inverse prime of x. That's what we're looking for. Right now I've called it dy dx. So like with the other implicit differentiation we did recently, we're going to solve for dy dx by just dividing both sides by f prime of y. And so right now we have it that dy dx, the derivative of f inverse, the derivative of an inverse function at any value of x that you want, is equal to 1 over f prime of y but that needs a little bit of explaining. That's a little bit confusing. So we'll see an example here. And this is one instance where it's a little bit simpler if you take the x and y out of it and just think of them as two constants. So this is the same, this function formula that you see right now is the same formula, but what I've done is replace the variables with constants. So f of a is equal to b, meaning that the coordinate ab is on f of x, and that also means that b comma a is on the inverse of f of x. That's something to keep in the back of our mind. So the derivative, I'm going to read this sentence now. The derivative of an inverse function at any x value, b, is equal to the reciprocal of the derivative of the original function, not f inverse, but just f, evaluated at x equals a, where a is the specific x value whose y value is b. This sounds very complicated and confusing. I promise this is one of those times when the actual work is easier than it sounds it's going to be. So let's do an example where we're given a function, and then we'll see a couple of examples where we're not given a whole function, we're just given specific values of the function. Let's try it this way first. F of x is x cubed plus x. I want to find f inverse prime of 10, meaning the derivative of the inverse of f evaluated when x equals 10. And when we say evaluated at x equals 10, that means evaluated when x, the input into the inverse function is 10. Now, you can see why this might be a little bit problematic, because I can't really find the inverse function. It's not so simple. Remember, with inverse functions, we take the y equals x cubed plus x, and we switch the x's and the y's around. X equals y cubed plus y. That is the inverse of x cubed plus x. The problem is I can't solve for y there. I just can't. There's nothing I can do to solve for y there. We don't have algebra skills for that. So we need a different way to find the rate at which the inverse function is changing. So here's our process. We're going to start by finding and labeling f prime of x. If f of x equals x cubed plus x, then f prime of x is 3x squared plus 1. No tricks there, just the derivative using the power rule. I'm going to keep that on the back burner for just a minute. Step 2, we need to find f inverse of 10. Because if we look at the formula up here, if we want to find f inverse prime at 10, then we need to know what this other value is, what the a is, the number that corresponds to 10. The idea is what corresponds to 10 is if 10 is the input into our inverse function, that means it's the output on the original function. So what we need to find is what is this a? What is the original input into our function f that gives us an output of 10? That's what this is, f inverse of 10. I want to find the x value whose y value is 10. Well, sometimes this leads to hard equations to solve. In this case, we're just going to kind of look at it for a second. And although we don't really have the algebra skills to do this by hand, what we can do is just kind of with guess and test here. We can see that a number that works there is 2. 2 cubed plus 2 is equal to 10, which means that the point 2 comma 10 is on f of x. Or maybe another way to say that is that f of 2 equals 10 and f inverse of 10 equals 2. So that is the number that goes in here, which is going to be the number we need to find down there. So we're going to find f prime of that 2. F prime of 2, since we just found out what f prime of x is, we can just plug a 2 in there. 3 times 2 squared plus 1 is 13. And so the reciprocal of that, 1 over f prime of 2, is 1 over 13. That is f inverse prime of 10. And you might need to watch over that again and see the steps and see how it works out, because that was a little bit tricky. The truth is that the problems you'll have to answer, especially on an AP-style exam, are actually easier than this. So let's take a look at a couple of those. This one, number 40, you can see it actually is an old example from an AP exam. Let f and g be functions that are differentiable everywhere. All of those words are important, but try not to get bogged down in them. They're just background that lets you apply the rules that we've been learning in here. It doesn't change the way you're going to do any of your work. The next part is where it starts getting important. If g is the inverse of the inverse function of f, and g of negative 2 equals 5, which, by the way, is another way of saying that f of 5 equals negative 2. Remember, that's what it means for functions to be inverses of each other. And f prime of 5 is negative 1/2. Then g prime of negative 2 is what? And so this is where we're going to use the formula again, that the derivative of an inverse function, and I find it a little bit easier to actually, instead of calling it g, I'm going to call it f inverse. So if we want to find f inverse prime of negative 2, it would be equal to 1 over, or the reciprocal of, f prime, not f inverse prime, but f prime of whatever number corresponds to the negative 2. Well, we saw before, if g of negative 2 is 5, that means the 5 and the negative 2, they go together. So we need to find out the reciprocal of f prime of 5. Well, that's not hard. 1 over negative 1/2 is negative 2. So that's our answer. We'll do another couple of examples until you get the hang of it. Remember, feel free to rewind and watch again, if that'll help. So h of x is f of g of x. We want to find h inverse prime of 2. Well, in order to do that, we need to find h inverse of 2. Actually, I'm going to do that second, because according to the steps I gave you on the last page, we're going to find h prime first. h prime of x first. So h prime of x is, well, if h is a composite, then its derivative is just the chain rule, f prime of g of x times g prime of x. We're going to hang on to that for just a moment. We need to find out what number we're plugging into that derivative. Because remember, our final answer, the derivative of our reciprocal, is going to be, change colors, is going to be, sorry, the derivative of our inverse function is going to be the reciprocal of the derivative of h evaluated at some number we haven't found yet. I need to find out what that number is. That number is going to be h prime of negative 2. So we need to figure out what value h inverse of negative 2, sorry, h inverse of positive 2, means what number, when you plug it into h, will turn out to be 2. Well, we can figure that out. H is f of g of x, which means that the last thing that will happen to the function h is whatever f does to a number. And if the result of that is supposed to be 2, I just need to look down the column for f of x and say, what number as a result of 2? 3 has a result of 2, which means that g of x, in order for f of g of x to turn out to be 2, g of x must be 3. Well, when is g of x 3? Well, only once. G of x is 3 only when x is 1, which means if the original input is 1, then g of 1 is 3 and f of 3 is 2, which means the result of h will be 2 as long as the original input is 1. I know there were a lot of steps there, so you might need to replay that and see it again. But now that I've figured out what h inverse of 2 is, we can plug, it's 1, we can plug that in to the reciprocal that we had up here and say that h inverse prime of 2, sorry, h inverse prime of 2 is equal to the reciprocal of h prime of 1. And we can figure out what h prime of 1 is by plugging a 1 into here. So I'm going to do that separately down here just to make it a little bit easier to read, but you of course could just do it right down here if you wanted to. H prime of 1 is f prime of g of 1 times g prime of 1. And we'll do some evaluating here. Is f prime of g of 1 is 3. G prime of 1 is 10. And f prime of 3 is 7. So we have 7 times 10, which is 70. And so that's going to go into the denominator of our derivative of our answer. I'll do one more actual AP problem. And this one is easier than the table, but a tiny bit trickier than the number 40 we just did, only because they give us a little bit of extra information here. So f is a differentiable function, and f of 3 is 15, f of 6 is 3, f prime of 3 is negative 8, and f prime of 6 is negative 2. There's no way we're going to use all of that information just to find one derivative. G is the inverse of x, and we want to find g prime of 3. Which, again, I think it's helpful to think of that as f inverse prime of 3, which is equal to the reciprocal of f prime of some number which is the input whose output in f is 3. Right? So what we need to do is find g of 3. G of 3, which remember is another way of saying f inverse of 3, is the input whose output is 3, that is right there, 6. So we need to find f prime of 6 and find its reciprocal. Well, they told us that f prime of 6 is negative 2, so f inverse prime of 3 is the reciprocal of f prime of 6, which is negative 1/2.